2007, a consortium of policymakers, scientists, and conservation professionals began developing a technology to assist in rapid ecosystem service assessment and evaluation. This web-based system, called ARIES, pairs local knowledge with that of experts, allowing users to better understand the value of the planet we share.
Ecosystem services are the benefits that people receive from nature, which contribute to our economic, personal, and common well-being. Ecosystem benefits include the provision of raw materials, the regulation of environmental conditions, cultural benefits, and psychological benefits. By including ecosystem services in decision-making and mapping them in the landscape, you can ensure that important values are not overlooked.
ARIES is built as a system that will link beneficiaries and ecosystems that provide ecosystem services across the landscape. We go through the existing literature, look at models that have been put together by other scientists, and we interview local experts, and we use all that knowledge to develop conceptual models of how ecosystem services are provided. Not only do we map the ecological relationships in providing ecosystem services, but we also map the location of the people who benefit.
We try to establish how much the benefits coming from nature flow to people, and that flow is what we try to value.
Unlike other models, ARIES is designed to work under conditions of uncertainty or data scarcity.
Even if you have all the data you need, which is never the case, all the data carry uncertainty with them. What you want to do is to give a decision maker a tool where the decision maker is capable of realizing not only what is the most likely final number that you're going to reach, but what is the distribution of all the other possible outcomes. Instead of building one model, we give the system the ability of building models for specific situations under the guidance of data and users.
When we learn more about system and we get more facts, we update those probabilities according to Bayes theorem. And the more data we get about system, the better our models. We think that this is most promising element of Bayesian networks which can be applied to the problem which are so significant for ecological economics.
In ARIES, the landscape is seen as a place where ecosystem services are distributed unevenly but predictably.
Instead of visualizing the world as an arbitrary breakdown of pixels by using a grid, like is on this graph paper here, instead, the ARIES system searches through those pixels and groups them together into regions where ecosystem services are provided or used in similar ways. We can collect together the statistical distribution of the variables in any given region, which sets the stage for using probabilistic models. The regions themselves in space actually represent more meaningful objects to decision makers than saying, well, this group of pixels over here provides a particular service.
ARIES is designed to account for nature's biophysical and monetary values.
ARIES can measure value in several different ways. It can look at the biophysical values, for example, the tons of carbon sequestered by a healthy ecosystem. It can also look at the benefits those biophysical values confer on society. For example, looking at the people's lives and livelihoods protected by a forested watershed from flooding. It's a very transparent process to transform those biophysical and social benefits into monetary values. A lot of studies rely on benefits transfer. They take a value from one ecosystem elsewhere and apply it to a different ecosystem. Often the estimates are very inaccurate. ARIES can adjust benefit transfers by the change in quantity of the ecosystem service or the structure that generates that service in the new system.
Valuation is informed by the concept of ecological thresholds.
We take account of scarcity of the resources, especially the extent to which they are essential and non-substitutable. As resources become increasingly essential and non-substitutable, their values will increase dramatically in response to small decreases in quantity.
ARIES is designed with both a technical and non-technical user interface.
We're trying to have a flexible approach that gives us the possibility of making both the scientist and the decision maker happy.
Users start by selecting a geographic area and ecosystem services of interest. A rule engine or interview process helps the user make decisions on whether to include or exclude data on the location and services of interest.
In general, the rule engine is some sort of a watchdog that watches over you as you type things and as you set your priorities, and tries to understand how you're thinking and what you want, and tells the machine to build the models in different ways.
Users can explore scenarios where the probability of ecosystem service factors might change.
The important things that ARIES can do is to help people really understand the trade-offs between different types of land management or development or conservation decisions. We'll really be able to more specifically pinpoint where ecosystem services are provided and who they help.
ARIES is being developed to meet the needs of different user groups around the world.
Forests in Madagascar provide local benefits, for example, the retention of soil, and at the same time they provide more global benefits such as carbon sequestration. By being able to map and assess these ecosystem services, we will be able to plan for a conservation that is inclusive of these values.
In Washington State's Puget Sound, catastrophic floods have significant ecological impacts.
We expect to achieve a lot with ARIES. We're working with cities, counties, tribes, storm districts, water districts, utilities. All these institutions are interested in how ARIES can help them manage their natural resources and rebuild our natural capital.
In Mexico, the municipality of Coatepec is interested in using ARIES to map hydrological services provided by upstream cloud forests. ARIES will be applied to a small watershed where a mechanism of payment for hydrological services is in place.
There are so many things that excite me about working on the ARIES project. As a computer scientist who's really interested in environmental issues, this project has really opened up the door to finding so many connections that I've never seen in any of my classrooms before. Opportunities to use techniques like machine learning, pattern recognition, knowledge representation, and reasoning under uncertainty. There's so many things in theoretical computer science that can be applied to environmental problems that are not being used right now. The thing I love about ARIES is the opportunity to bring all of these techniques to the table.
It is our hope that ARIES can provide an improved understanding of how ecological benefits flow from ecosystems to people. Its probabilistic approach explains how much uncertainty is associated with results, while also allowing users to operate the system under conditions of data scarcity. We believe that ARIES provides an important tool to advance both the science and policy of ecosystem services.